Welcome back to the ARTtech seminar. So the next speaker is an experienced professional in mobile games, and we'll be specifically talking about location-based games. From Shipyard Games, please welcome Teemu Harju.
Okay. Hello, everyone. My name is Teemu Harju. I'm the CTO and co-founder of a gaming company called Shipyard Games. And I'm here to talk to you about location-based gaming. A quick intro to our company. We're a fairly new company, founded a year and a half ago. At the moment, we employ 6 people, and we're located in Helsinki, Finland, the gaming capital of the world. Quite big part of our company has been working on location-based games from 2010. And the company vision is to build a new genre of location-based gaming. We're just about to soft launch our first title, and it's called Go City. A bit overview for the presentation. I'm first going to talk about the tech. In location-based gaming, maps play a big part, and the tech part in my presentation is largely dealing with how we are generating the game worlds based on real-world map data. Then, since this is an ARTtech seminar, I decided to talk a bit about art. I'm no artist, and you will probably see that from my screenshots. But the idea here is to just give some pointers on how to visually make the maps more game-like. I will also talk a bit about gameplay. In location-based games, the gameplay aspects are very different from let's say, normal mobile games, and I'm talking about that a little. And then, in the very end, I'm going to talk about our first title, Go City. I think location-based games are kind of like augmented reality. We're just augmenting the reality using real-world data, map data. A big problem here is that traditional maps are just too boring for games. Obviously, maps are used to convey lots of information about where you are, what's around you, and they are way more informational than visual. And unlike games, which are highly visual experience. So if you're making a location-based game on top of, let's say, the way Google Maps or Apple Maps looks, it just feels weird. I'll briefly touch on the topic how online maps work. I think it was around 2005 when Google Maps came out as a browser experience, so a map that you could browse on a web browser. Back then, the maps were consisting of small raster images. Basically, the world is projected in a square. And to be able to load the entire world anywhere in the browser, the world is divided into squares and then divided further to smaller squares. And we kind of get the addressing of the tiles. For example, zoom level 0 has 1 tile, zoom level 1 has 4, and so on. And the deeper we go, the more tiles we need to do. So for example, our game is using zoom level 16, which means that there will be around 4 billion map tiles. And this is kind of the way that the maps looked back then. Raster images, intentionally a bit pixelated. Texts are wrong way around. It was impossible to rotate the map. Also, the raster images that were generated on the server and displayed on the terminal or the client or the web browser are difficult to customize and use quite a lot of data. And since then, the rendering capabilities of browsers and mobile devices have significantly improved. And kind of nowadays, we're getting maps that look like these. I guess the first thing that you noticed when the map tech improved was that you were able to actually rotate the map and texts were always pointing the right way. I think it was first Apple Maps that implemented this. This example is from Mapbox. So how this was achieved? Instead of sending raster images to the clients, we're sending vector data. And now the visual aspects are decided by the renderer on the terminal. And also the tiles can contain much more metadata than the raster images that were sent to the terminals. So, for example, we have different layers, land use, road, water, etc. These vector tiles contain features that are basically geometries, line, point, polygon, multi-polygon. And now that we've moved to using this way of representing maps, it obviously offers a lot more opportunities for making games. Here's one example of a more game-like map. And here is visualized how it's built from the tiles. So our current rendering engine is actually fixed on Zoom level 16. To get the map data, the easiest part is using openly available map data, and that's provided by OpenStreetMap. To be able to use vector map tiles, we're using a service called Mapbox. They have completely open specification for delivering vector-based map tiles. There's lots of available open source implementations. The implementation is actually really fast and efficient, and there's the link to the specification. It's a binary format based on Google Protobuffer, and it does quite neat tricks to make the size of the tiles efficient, way more efficient than the raster ones. And now, since we have vector data at our disposal, we can pretty easily generate 3D game worlds. This is an example, just quick render of OpenStreetMap data from Manhattan with extruded 3D buildings. And this is entirely built from data coming from Mapbox, using the vector tiles that I described. For the gaming purposes, these different data layers allow us to do pretty cool stuff. We know where the player is moving, what's kind of around them. But implementing this ourselves, there were some tricky parts. Basically, the data coming from the vector tiles is just screen coordinates of polygons. And to be able to render that using a 3D renderer, we need to do triangulation. Sounds easy at first, but the data that comes from maps is actually quite hard to triangulate. One tricky part is also roads, which are basically only lines. And since all the data is divided into tiles, like I explained. It generates quite some nasty geometries. This is one example. This is actually from Linnanmäki, Hurjakuru on the map. I've been using that while testing our map renderer, especially the triangulation part of it. The red line there is the tile edge, where basically the whole thing is cut. We're using a ready-made triangulation implementation that is kind of not perfect, but tries to solve cases like self-intersecting coordinates and stuff. So we don't want the map to crash when the player is panning around the map. It needs to work everywhere, and it's quite hard to find all the edge cases. So it's just kind of better to gracefully or try to render something always. Here are roads generated from the vector data. So what we need to do is to represent just basically the lines on a map, give them certain width, and triangulate them. There's a few different ways we're doing it. We're either directly offsetting the line strings and then triangulating them. And when we want to do a bit more dynamic width for the roads, we're using custom shaders. One tricky part also is having, like I mentioned, having holes in the polygons. This is how Mapbox vector data represents holes. And for that, we need to first figure out the winding order of the polygons. And just remember that basically everything we do for the map data, we need to support basically all these cases. Like I mentioned, basically the entire world is available as a free data. Well, the honest answer is that generally countries in Europe and North America have quite a good coverage. All bigger cities are mapped quite well. The direct OpenStreetMap Planet file is about 68 gigabytes of XML. I think that's pretty cool. The map data is constantly updated, around 30,000 changes every day. There are efforts into improving the data automatically. Currently, all the OpenStreetMap data is mapped by users. But there are efforts on using machine learning from satellite imagery to get even better maps. For example, Pokemon Go is using OpenStreetMap, and that's actually heavily improved the, let's say, people's willingness to update the map. And for example, like I already mentioned, Mapbox provides easy access to the OpenStreetMap vector data. A few words about game engines. When we started making our first game, let's say a year ago, there weren't ready-made SDKs available. We went to the route that we're going to write our own. Since then, for example, Mapbox and Google have released Unity SDKs. And both of them are using vector data as much as possible. And there are already released games using, for example, Google's SDK. We decided to do it our way. In a way, it was a decision we had to make because there wasn't anything available, but also the games built with these two SDKs are basically what location-based games are nowadays, kind of like very similar to Pokemon Go. We have a way to customize our own engine way better and make a different kind of games, location-based games, more easily. Okay, then I'll talk about how to generate worlds from map data. Like I already said, traditional maps usually offer lots of information, or as much information as possible, because people need to know what's happening around them. So here's a very, very crude render of basically everything that map can contain. And this represents kind of the real world. That's not very much fun when we're thinking about games. Real world tends to look very real. And I would say it really easily looks really boring. This is from Manhattan. And it's quite difficult to say quickly where in Manhattan that is. Unless they're, like traditional maps uses, let's say, road names and stuff that makes it easier to recognize. But when you're making games, we feel that stuff like that doesn't belong to the game world, so we can make them more game-like. In a way, recognizability is a key here. In some aspects, it's difficult for the user when they start the game for the first time even to know that this is a location-based game. So let's say if the first feeling of the game is that it's a bit crappy-looking game that has weird levels, and I actually don't know this is a location-based game, that's the kind of the worst case scenario. So we believe that kind of less is more in terms of using the map data. There's lots of data available, and you need to pick really carefully what you're showing in your game. Usually the higher you are from the map, the area gets way more recognizable. Here's one example again from Manhattan. If you would be playing a GTA-style great game between these skyscrapers, it's actually quite easily quite bad experience. Whereas on the right-hand side, you will immediately recognize where you are. A big part of this is also that real-world cities have not been designed as game levels. So it's quite tempting to think that we're making a GTA-style action game in a city, whereas cities are actually quite boring. Some are a huge mess. I don't know if there's been any planning behind some cities. And gaming experiences need to be quite well thought, kind of well, have a nice rhythm, and that just doesn't happen in real world. One aspect also affecting heavily in location-based games is, I guess it's called uncanny valley effect. It's a concept mostly used when talking about humanoids. The quote there, which appears almost but not exactly like human beings, it elicits uncanny or strangely familiar feelings of eeriness and revulsion in observers. Sounds pretty cool, but basically it means that the more closer you try to imitate the reality, the more weird it starts to feel. And when making location-based games, I think this is a really important concept to keep in mind. It's again really tempting to try to make the exact replica of the real world, and I would say that currently it's nearly impossible to achieve it at the level that it wouldn't feel weird for the users. quite common way to solve this problem in location-based games that are out there is to create some kind of a post-apocalyptic or like imaginary worlds. I'm showing few fairly recently released location-based games: Jurassic World Alive, Walking Dead Our World, and Moomin Move. From all of these, you easily can see how this problem has been solved. For zombie apocalypse, I would say that's the absolute coolest location-based game theme that you can make, and maybe probably by far the easiest. In our yet unreleased title, we're aiming to do something a bit more casual. So all the learnings I've explained here are kind of immortalized in these images. We're trying to avoid these kind of post-apocalyptic themes so that the game would be a bit more approachable, but also make it not look too real, so it makes it feel weird. Like I said, we also think that making the game recognizable helps when you are able to go a bit further up in the map. This particular image is actually from Lauttasaari, the junction that is attaching to Länsiväylä. Maybe at this height even it's quite difficult to figure out where you really are. Also, we have pretty or used quite a lot of attention on picking the data that we are showing on the map. As you can see, it's quite little, basically just different land layers, some pretty carefully hand-picked roads, and trying to make it look like a game rather than a map. That was for the art. Then I'm going to talk a bit about location-based games regarding, let's say, game design or gameplay. Kind of an obvious statement is that location-based games are inherently mobile. And this is quite common comment that you get once you release a location-based game. This is actually from app reviews of The Walking Dead Our World. You need to really carefully think, like, what's the value of the assets in your game? Is it really something that makes the player want to go walk out in the rain to get something? We have like this idea that we would like to build our location-based games to be a bit easier to play on the couch, but have the right amount of the moving in the game world, because that's kind of what really makes you feel that you are playing in the real world. So ideally, the game kind of blends with the real world. I've used the term here like poor man's augmented reality, like I mentioned earlier already. It's kind of augmented reality that we are building. In a way, you just kind of have to imagine and feel the game world around you. Obviously, it would be fairly easy to add AR capabilities to the game. Unfortunately, maybe the tech is not there yet to make it really feel like you are in let's say in our game, which is a city building game, that you would actually feel that you're in that city. For example, occlusion with real world objects is, I think, the biggest thing that's kind of preventing. Augmented reality in this sense is kind of a gimmick, unless you're making a measuring tape app or something where it actually can be useful. But yeah, so far, unfortunately, you kind of have to imagine the game world around you, and it really, I think it really adds the location aspect really adds a new aspect to the game. So when you're walking into your own city, it needs to feel special. Then I'd like to touch a bit about like a game design aspect from a example that I kind of found from my childhood. I was a big fan of a game called Civilization, and how it relates to location-based gaming is that that game had a real-world map where you could also play it. So for those who don't know what's Civilization is a strategy game where you build your own empire and compete with others on a basically procedurally generated game map. But one specialty of it was the real-world map, and I think this shows quite nicely how hard or almost impossible it is to design a good location-based game. So this is how the game looked back then, some 90s something, and here are the starting points of different empires, like let's say Americans or Englishmen. So in there, I think the coolest aspect of it was that when you're starting the game, you already know quite a lot because you know where different countries are, and you have some idea where the important cities are and where your rival civilizations are based. And this is kind of the same idea in location-based games heavily, or it has to be. But kind of not all nations start with the gameplay with equal resources. For example, if you look at England, it would really suck to start the game from there. And in a way, this scales pretty nicely to location-based games anywhere. So we need to be aware that the player can start the game basically on a remote island. And that's a problem that needs to be somehow addressed. To sum it up, so it's nearly impossible to control the gameplay in location-based games. The players will always start the game in different conditions, and this makes everything difficult. Especially the onboarding part in the games is quite hard to make because you have no control where the user will launch the game for the first time. Okay, this was the part of the making location-based games. I'd like to show you a bit about our game that we've been working. Surprise, surprise, it's a location-based game. It's a location-based city building game. And the idea here is that you build your city where you move. To be able to limit the gameplay area, everything builds around roads. To be able to build something, you always need to build a road there first. And to be able to buy or build a road, you need to be close enough physically. Otherwise, you're free to do anything in the world. So pretty much the only limiting factor is the roads. Very traditional city building game. You collect money to further your game, build even a bigger city. Commercial buildings generate money from residential buildings that are close by. You also need industrial buildings to support your city. But basically, game-wise, this means that you can have more population. Also, the industrial buildings have a negative effect on the residential buildings that are too close. Basically, quite simple SimCity-ish approach, and it's all based on a real-world map. A big part of location-based games, like I mentioned, is discovering stuff while you're moving around. In our game, you find new buildings as you move around, and then you're able to upgrade them to bigger buildings. One interesting aspect is also finding real-world landmarks from their real-world locations. Okay. That was basically what I have. To wrap this up, building blocks for location-based games are out there and basically available for everybody. And I think the world is more ready for location-based gaming than ever. Pokemon Go did a nice job in educating people about location-based games. There's been multiple games released since. But I think our game will have a new and different angle in location-based gaming. Like I mentioned, the vector map data allows us to generate more and more complex game worlds. And just as a side note, designing a working location-based game is extremely hard. We are, at the moment, soft launching our game and testing it with actual players, so we get feedback that is really important for us to make the game really work. It says here that GoSid is coming. It's definitely coming. I cannot promise anything yet. But if you're interested and if you're bold enough to try a game where maybe the entire experience is not completely polished, and the game might change a bit while you're playing it, but you're free to sign up for our beta and start playing. Unfortunately, the game will be available only at the moment only for iOS. Yeah, that's all from me. Thank you.
If you have any questions, we have a few minutes.
Regarding it being, open vector map and everything, will you be able to see other people's creations?
We have some plans on doing it. For the first part, the game will be a single player experience. There are some really difficult problems to solve, even in terms of privacy, that we want to be really careful about. But I think in a way, Pokemon Go showed that actually a single player single player location-based games can work, and trying to bring obviously a multiplayer aspects, but especially with the city building game, we kind of need to be somewhat cautious with the privacy aspect, and also multiple players building at the same location is actually quite a difficult problem to solve. Everybody had the same question.
What about with battery consumption? That's been a big issue on these games.
It has, yeah, I completely agree. And in a way, I mentioned that we developed our own engine to build this game. I think it will help us a bit. we're a bit closer to the native APIs and try to use them as let's say carefully as possible. But basically, there's like three things that consume battery. It's like using GPU heavily, using network heavily, and using location or GPS heavily. And that's basically all we are doing. So I think in a sense, location-based games are kind of always will have that issue. But yeah, we're working hard to not make it consume the entire battery immediately.
Okay, thank you very much, Teemu.
Thank you.